In graph theory, circular coloring may be viewed as a refinement of usual graph coloring. The circular chromatic number of a graph, G, displaystyle G, denoted chi C G, displaystyle chi underscore C G, closing curly bracket, can be given by any of the following definitions, all of which are equivalent. For finite graphs, chi C G, displaystyle chi underscore C G, closing curly bracket, is the infimum over all real numbers, R, displaystyle R, so that there exists a map from V, G, displaystyle V, G, closing curly bracket, to a circle of circumference 1 with the property that in any two adjacent vertices map to points at distance 1, R, displaystyle GEQ frac 1 R. Along this circle, chi C G, displaystyle chi underscore C G, closing curly bracket, is the infimum over all rational numbers, n k, displaystyle frac n k, so that there exists a map from V, G, displaystyle V, G, closing curly bracket, to the cyclic group Z slash n Z, displaystyle mathbb Z n mathbb Z, with the property that adjacent vertices map to elements at distance k, displaystyle geq k, apart. In an oriented graph, declare the imbalance of a cycle C, displaystyle C, to be pipe E C pipe, displaystyle E C pipe closing curly bracket, divided by the minimum of the number of edges directed clockwise and the number of edges directed counterclockwise. Define the imbalance of the oriented graph to be the maximum imbalance of a cycle. Now, chi C G, displaystyle chi underscore C G, closing curly bracket, is the minimum imbalance of an orientation of G, displaystyle G. It is relatively easy to see that chi C G, chi G, displaystyle chi underscore C G, leq chi G, closing curly bracket, especially using 1 or 2, but in fact, chi C G equals chi G, displaystyle lceil chi underscore C G, RCL equals chi G, closing curly bracket. It is in this sense that we view circular chromatic number as a refinement of the usual chromatic number. Circular coloring was originally defined by Vince, 1988, who called it star coloring. Coloring is dual to the subject of nowhere zero flows, and indeed, circular coloring has a natural dual notion. Circular flows, circular complete graphs, for integers n, k, displaystyle n, k, such that n, 2, k, displaystyle n, geq2 k. The circular complete graph knots k, also known as a circular clique, is the graph with vertex set z slash n z, displaystyle mathbb Z n mathbb Z, and edges between elements at distance k, displaystyle geq k, apart. That is, the vertices are numbers 0, 1, n1, and vertex I is adjacent to I plus k plus 1, I plus n k mod n. For example, knots 1 is just the complete graph knots, while k2 n plus 1, n is isomorphic to the cycle graph c2 n plus 1. A circular coloring is then, according to the second definition above, a homomorphism into a circular complete graph. The crucial fact about these graphs is that K-B admits a homomorphism into KC, D if and only if A, B, C, D This justifies the notation, since if the rational numbers a, b and c, d are equal, then car, b and kc, d are homomorphically equivalent. Moreover, the homomorphism order among them refines the order given by complete graphs into a dense order, corresponding to rational numbers. 2. Display style GEQ2. For example, K2 over 1 K5 halves K7 thirds, K3 over 1 K4 over 1, or equivalently, K2 C5 C7, K3 K4. The example on the figure can be interpreted as a homomorphism from the flower snark J5 into K5 halves approximately equals C5, which comes earlier than K3, corresponding to the fact that chi C J 5 2.5 less than 3. Display style chi underscore C J underscore 5 LEQ 2.5 less than 3. See also rank coloring. Nadolsky, Adam. 2004. Circular coloring of graphs. Graph colorings. Contemp. Math. 352. Providence. Re. Amer. Math. Soc. pp. 123 to 137. DOI. 10.1090, CONM 352-09. Mr. 2,076,994. Vince. A. 1988. Star chromatic number. Journal of Graph Theory. 12. 4. 551 to 559. DOI. 10.1002, JGT. 3,190,120,411. Mr. 968,751. Zhu. X. 2001. Circular chromatic number. A Survey. Discrete Mathematics. 229. 1 to 3. 371 to 410. DOI. 10.1016, S0012365X. 0000217X. Mr. 1,815,614.